in the industry. My specialty is actually in direct modeling, and we have webinars on that. One of the things I love about Fusion, as-built joints, T-splines, built-in cam, pretty much everything, honestly. And we actually have webinars on all of these topics too, which you'll see here in just a moment. I mentioned I'm a Fusion Success team member, and we're a group committed to making customers more productive with Fusion 360. I've got dedicated experts on my team to help quickly close the knowledge gap, and these webinars are one of the ways that we do this. So by the end of this session, we should have a basic understanding of what is sheet metal inside of Fusion 360. We're going to learn about sheet metal rules. We'll talk about the Flange tool, folding and unfolding, and then flat patterns, and then finally like documenting and manufacturing your sheet metal parts. So I have some screen captures. This is actually one of the very first things we did when we first released Fusion. I'm sorry, when we first released sheet metal into Fusion. We created a challenge, and we had a whole bunch of people all over the world to design a sheet metal bumper for this vehicle. And so here's a couple of the ones that were sent in, and then the one that ended up winning actually got manufactured in Pier 9 and installed on the vehicle. We're going to be creating more stuff like your standard sheet metal parts like this. In fact, we're going to create an outlet box. I'll walk you through that. In this Sway document, I have some live links. For example, this link right here will take us to upcoming events. And I mentioned we have many different webinars. So you can see, for example, we're in this sheet metal webinar right now. What is Fusion? Don't fear the 5-axis, rendering, generative design, etc. So as I scroll down, you'll see we've got a couple ones in here. So that's the rendering, direct modeling, drawings, etc., assemblies, sketching and part modeling. So if you haven't signed up for these, I highly recommend you do so. I also know that you can't always attend these webinars at the particular time and date that we offer them. So we do have most of them recorded. And there's a link here that would take you to these recordings. So for example, sketching and part modeling, direct modeling, rendering, etc. Okay. Now this session is being recorded, so you will all get a follow-up email with a link to that recording. I'll also include a link to this document here, so you'll have access to these live links. As we're going through, please feel free to post any questions you have out into the Q&A section. For example, I already see, looks like Jerome posted one. It says, is there an easy way to add reinforcement creases to large sheet metal panels? Excellent question. In our sheet metal module, not at this time. You would actually have to make them yourself, but then you have to figure out, how is this going to be manufactured? Will it lay out flat? That kind of a thing. So this is a good lead in. This is a really good question. The sheet metal we have is kind of our first version of it. They are constantly enhancing and adding more stuff to it. So you'll see that in future releases. So hopefully we'll see reinforcement creases, because I know they do that a lot in sheet metal. With that said, I recommend going to your help menu and under community, idea station. You can actually post your ideas out there, and this is what R&D and management is looking at on adding enhancements into the product. So definitely go out there, search for it first in the idea station. If you don't see anything in there, add in your idea. I recommend including pictures or examples or whatever. People can vote for that, and that's what helps get things into future releases. So thanks for asking that. So just like Jerome did, there is a Q&A section. Please feel free to post your questions out into the Q&A. I prefer that versus the chat, because I can't really see the chat window like I can the Q&A window. Okay, so let's dive right in. This is what we're going to be basically creating today, is this sheet metal box, this outlet box. Okay, In fact, if I turn off the 2x4, you can kind of see there's a hanger on the side, etc. So we're going to learn about how would you go about creating something like this inside of Fusion 360. And one of the things I love with our sheet metal is think about how long it would take you to make something like this just using regular modeling commands. Well, the sheet metal commands really speed things up, make things much, much easier to use. And we're going to learn about all these different commands. Now, I am using our preview user interface. So my screen might look slightly different than yours. So you'll notice that we have some tabs across the top: solid, surface, sheet metal, etc. And it kind of changes the menu across here. If you're using the older user interface, you would find sheet metal over here in your pull down. Okay, exact same commands. There's nothing different here. It's just how things are organized. And if you want to give this a try, you go under your name, preferences, and then under preview, you'll want to turn on this UI preview. So recommend doing that. I really like it. I've been playing around with it for about a month now. I find it really, really handy. Okay, so I am in my regular modeling, which we now call design, modeling tab. So here's all your modeling commands, such as fillet and shell and chamfer, etc. But across the top, I'm going to go into sheet metal. And there's really not a lot of commands in here. And the reason for that is this flange command is actually about 4 or 5 commands in one. It's kind of like the press pull command, where you can offset a face, you could create a fillet with it, you could, move things, etc. with the press pull command. Well, it's kind of the same thing with the flange command. So we're going to learn about that. You'll notice that there's, under the modify, there's unfold command. And then there's also this sheet metal rules. And I'm going to start with this. So I'm going to go ahead and click on sheet metal rules. And you'll notice it brings up this menu. And it's kind of broken down into 2 areas. You'll see in this design, and right now there's nothing in this design, so there's nothing underneath it. And then there's the library. And in the library, we have some standard materials. So you'll see, for example, steel, stainless steel, and aluminum in millimeters. Then you'll see the same thing: steel, stainless steel, and aluminum in inch. Okay. And then there's a couple other ones you'll see here, and these are ones that I added. And I'm going to walk you through how you can create your own rules. And you might say, well, how come you don't see all the, the 12 gauge aluminums and all these different kinds of materials? And when we were creating the sheet metal module, we interviewed a lot of people, a lot of sheet metal shops, and they all said that pretty much all sheet metal is different. So, if it's stainless steel, it might be this particular thickness. If it's regular steel, it might be this particular thickness. And creating a huge library like that would really not benefit a lot of these shops. They say they create their own materials. So we just kind of gave some basic ones, and then you can create your own. So for example, let's just go ahead and do this aluminum, and you can see it says edit rule or new rule. Okay. If I expand this guy open, we can see what the thickness is, the K factor, et cetera, bend conditions, corner conditions. So these are all the rules. And what this basically is saying is when I create a part and I select aluminum, it's going to be 0.08 inches thick with a 44% K factor. It's going to have round relief shapes for bends and round relief shapes for intersections, etc. Okay, that's basically what it's saying here. So I'm going to come in and say new rule. Okay, and I can give it a name. So I'm going to leave it aluminum inch, but I'm going to come in here and say, like, let's just make it 0.25 thick. We'll make it pretty thick here. And then I can add in the thickness. So let's just make that 0.25. Okay. K factor, again, this you kind of have to know for the material you're using. So for metals, it's typically around 44%, and that's why you see the 0.44. If it's cardboard, it might be much lower or higher, depending. If you're bending plastic, if you're bending carbon fiber, whatever it might be, you might have different K factors. So again, depending on the material that you're creating, you might want to know what the K factor is. And a lot of that information is available out on the web. Okay. Now here's what's interesting. You'll notice it says miter gap, rip gap, and seam gap is all set to whatever thickness is. So it's going to be 0.25. So my miter, rip, and seam gaps are going to be whatever thickness is. So that's, you can use variables. In fact, you'll see here, for example, if I expand open bend conditions, the default bend radius is going to be thickness, 0.25. However, my like relief depth is going to be thickness times 0.5. Same thing with my relief remnant, and I'll talk about that here a little bit later. We can see our relief shape. We can do straight, tear, or round. Okay, and I'll show examples of each of these. So basically, straight is going to create like a rectangular relief. Tear is going to hardly leave any relief at all. It's almost like you're just tearing the metal. And then round is going to leave a round relief. If I go into my corner conditions, we can see, for example, for two bend intersections, it's going to do a round relief, or square, tear, trim to bend. You see we have lots of different ones, and I'm going to show these here in just a moment. So just for fun, let's make this one square. We'll make the relief round, we'll make the intersection square. And then you can see the relief size is whatever thickness is times 4. And you can come in and edit any of these. You could say, you know what, I want that to be times 3, let's just say. Okay. I'm going to leave it 4 for now, but you can change that. And then same thing with relief placement. You can see we have options depending on what you've selected here. Intersection, 3 bend intersections, lots of options here. I'm going to leave this alone, and this will make more sense once we get further along. Okay, so that's basically how you create your own rule. You specify the thickness, the K factor, and then some of these options in here. I'm going to go ahead and hit save. And now you'll notice, let me just click up here. You'll notice that there's a new material in here called aluminum 0.25. Okay. So what that means is when I go to create a sheet metal part, I can specify that material as my rule. So I specified my rules and they get saved automatically. So if I start a new session, that new material will be in there. Okay. The next thing I want to do is, you'll notice in the create menu, the very first thing says new component. And when you're creating your sheet metal parts, you definitely want them to be components. So I'm going to say new component. And it looks similar if you're familiar with bodies and components. This looks kind of like the component menu, where it allows me to give it a name. So let's just call this demo. The parent's going to be selected. It's going to be active. But here is the important thing. Right here, I'm going to check sheet metal component. And now it's going to show me my library. And I can come in here and say, let's go ahead and select this new material that I created and say, OK. And it's going to be a little hard to see, but you can kind of see there's a new icon for the sheet metal component. It looks kind of like a folded piece of metal. Okay, it's active. I can go ahead and create my sketch. So let's just start with a basic rectangle. And let's just make it maybe 4 inches by 6 inches or something like that in this case. I'm going to say stop my sketch. So I just created a 4-inch by 6-inch box. Then I'm going to use the Flange tool. Okay, and like I mentioned before, this is many commands in one. So I'm going to say Flange. Move this over so you can kind of see it. And I'm just going to select on my profile. And you'll notice something happen. It goes ahead and automatically extrudes it. And it's going to extrude it the correct thickness for our rule. So it's using that particular material. So we can see here, thickness, it says side 1. I'll say side 2 goes the other direction. So you have control over which direction is the material being added to. You could even say symmetric, and you'll see how it does it symmetrically, but let's just go ahead and leave it side 1. And I'll say OK. If I click on this edge, sure enough, we can see that it's 0.25 inches thick. So it created a basic sheet metal part using that rule. And that was the flange command, okay? I'm gonna select it again, and this time I'm gonna pick on, for example, this edge, and I'm gonna start to drag. Now you'll see a couple things happen. Now the first thing you'll see, and I will admit, this kind of annoys me, I always get this error message. And the reason for that is because as soon as I start to drag a little bit, it's trying to create that flange, but it can't. There's not enough material. As soon as there's enough material, you'll see that that error message goes away. So don't worry too much if you see that. But you can see I can now drag this, and it's creating this bend for me automatically. Okay. Now there's a lot of options in here. I'm not going to talk about all of them right now. I will talk about all of them here in a moment. But what this is basically saying is we clicked on an edge, and it's going to bend the whole edge. We have other options here, which I'm going to talk about in a moment. But right now, we're just bending this whole edge. I can also specify the height. Let's make the height exactly 3 inches. And now you can see how that kind of updated, and it says 3. We can change the angle of it. I can either manually grab the angle and drag it like so, or you could type it in. So I could say, for example, 35. And it's going to make 35-degree angle. Then we have this height datum, and I have a really cool demo I'm going to show here in just a moment that explains this. But you can see we can measure the height from the inner faces, the outer faces, or tangent to a bend. And basically what that's saying is, are we measuring the 3 inches from this top surface here to this top surface here? Is that the 3 inches? Or is it from this outside outer faces? Is it from here, the bottom, to the top? And I'll show you an example of that here in just a moment. Okay. Same thing with this bend position. Is the bend going to be on the inside, the outside, adjacent? Again, I have a really cool demo that I think really explains this better. You can also flip. Now I picked this top edge when I selected the edge, but maybe that was the wrong one. Well, I can just come in here and say flip. But then the cool thing in here is this override rules. I can activate this, I can turn it on, and I could come in here and say, you know what, I want to override this bend. By default, it's set to whatever thickness is, but maybe we want that to be, 0.5 inches instead. So you can see how it's actually going to bend that larger. Or we could make it 1.5 inches. We can see how large that gets. So you're not limited to what the default bend radius is. You can come in and change that if you want to. Okay. Same thing with like bend relief override. So let me show an example of this. I'm going to come in here. I'm going to change this into a tab, basically. And again, I'll talk about this more in depth later, but we can see when I brought this edge in, you can see how it created these bend reliefs. Okay. So let's go ahead and override this bend relief. We can see that the default shape is round. Let's come in here and make them straight, and now you can see how they're nice and straight. They don't have the rounded edges. Or I could come in here and say tear. And this is about here. We're basically just kind of tearing the material to create that bend. Okay. You could also change the relief width. And I don't know if you remember in the rule, the relief width was whatever thickness was. Well, I could come in here and say, let's just make that 0.125, and we can make that significantly smaller. I could even say 0.0125. So you have a lot of flexibility in here to create whatever you need for whatever material you're creating. Okay. So let's make that back to 0.25. Relief depth, same thing. Let's just go to 0.25. You can see how much deeper that went. Let's go 0.5. So again, you have a lot of control over this. And then the relief remnant, this is basically what has to be left. Watch what happens when I start dragging this guy. You'll see it'll jump away. So it's basically, that's what's necessary here before it actually will create the bend relief, okay? So that's what relief remnant is. Okay, so that's the basic flange command. So I click on flange, I click on an edge, and I specify the height. Okay, that's basically how you create a flange. If you add multiple edges, so I'm going to go ahead and add that edge in there, you'll notice that it actually creates the corner relief for me. And I don't know if you remember when I created the rule, I said I want round reliefs for the bends, and I want square reliefs for the corners. And so that's what it's actually showing here is a square relief. So let's come in here to this to bend, and sure enough, you can see relief shape is set to square. I could say I want it to be round. I want it to be a tear. Trim to bend kind of gives you a little bit of different option. And this one's kind of handy. You'll see later on, I could actually move these faces around if I want to, which is kind of nice. Linear weld and then arc weld kind of gives you a couple different reliefs. Now, one of the questions I get asked a lot is, how do you make these faces closer together? And that is in the rules with, all that spacing and all that kind of stuff. So for example, this relief depth, relief width, etc. If I made the relief width to be much smaller, that would be closer together. So again, that's just in your settings and your rules. Okay, so let me show you what I think kind of helps me figure out what are all these options in the flange command. So I created a block that is 2 inches tall, 3 inches wide, 4 inches deep, okay? 2 by 3 by 4, basically, okay? So I'm going to jump into my sheet metal, say new component, and I'll just give it a name. Let's just call it size example or something like that. I'll turn on my sheet metal component there, and it's going to allow me to pick a material. So let's go ahead. Let's do maybe 1/8 inch material in this case. I'll say OK. Create my sketch on that face. And it should be a 4 by 3, which you can kind of see there in the dimensions. Then I'll use the flange command. So I'm going to go ahead and click on this, and it's going to use that rule. Now notice it's a little bit thinner than the last one because we specified it to be the 0.125. I also want it to extrude down away from the box, so you can kind of see side 1 makes sense. If I said side 2, it would kind of come inside this box. And we're basically going to create an enclosure to hold this blue. I'm going to go ahead and say OK. Then I'll use my flange command, and we'll click on that edge. Now watch what happens when I start to drag, okay? First I get that message, which I said to ignore, but we can see that it's creating this sheet metal part, okay? Now we know that the overall height is 2, so I'm gonna type in 2, but you'll notice something kind of weird. It doesn't go all the way up to the top, okay? Now, why is that? Well, so our height is 2, our angle is 90, that's great. Our height datum is set to outer faces. So it's basically gonna measure from here up 2 inches. And in fact, it looks like it's short just about the thickness of the material, which kind of makes sense. So let's change our height datum to inner faces and notice what happened. Okay, so it's now measuring from the inside face, or what you might say is the top face right here, up 2 inches, and that's the exact height of the box. So that's what this height datum is basically allowing you to measure from. Is it from the outside to the top, or is it from the inside to the top? So in this case, I'm going to say inner faces for the height. And then you'll notice it says bend position is set to, actually just look at it straight on, is set to the inside. So it's actually bending, oh, maybe it's better in 3D, sorry. It's bending to the inside of that box. If I say outside, we can now see how that kind of jumped from the inside to the outside, okay? And it's perfectly touching our blue box. If I came in here and said adjacent, notice the result that we get, okay? When we said outside, sure enough, it goes outside that box, but because of the sharp corner, you wouldn't be able to fit this blue box in here. So I'm gonna come in here and say adjacent, and that actually gives me the space that I need. So you can see that it starts basically at the edge and then starts the bend with adjacent. And then lastly, tangent, which I don't have any, in this example, I don't have any tangent faces or whatever, so that one won't make much sense, but it basically creates the bend tangent to a face or an edge. So, but I don't have a good example of that. So I'm gonna leave this adjacent. Let's go ahead and maybe I'll add in that edge. We can see how it's doing the round corner relief. And we can see that there's enough space there. I'll come in here and add this edge. And then I'll come in and finally add this edge, okay? So I got my round corner reliefs on all of those, and we can verify that this box will fit inside this sheet metal enclosure. Now, if I came in here and said bend position was outside, you'll see how that all updates, and it fits perfectly around this box. And with how this is designed, that would actually work because of these bend reliefs and all that kind of stuff. It would still fit in there, but hopefully that makes sense with inside, outside, adjacent, and height datums. Okay. And again, if you have any questions, please feel free to post them out into the Q&A section, and I'll either answer them live or at the end, depending on the question. Okay, I'm gonna go ahead and say okay, and let's do the flange command again. This is actually pretty cool. Check this out. I'm gonna click on this edge here and start to drag. And again, we get kind of a preview what that's gonna look like. So it's doing bend position adjacent. If I said outside, you'll see it'll kind of jump down and now it's sitting right on top of my blue part. But in this case, we're gonna say adjacent to give us that little extra room. But watch what happens when I add in another edge. I'm gonna click on that edge. You'll notice that it actually automatically mitered the corner for us. And that's this right here, miter option, okay? So if I continue adding this in, I'll go ahead and say that edge. And then finally this edge here, we now have this sheet metal enclosure that's gonna hold this blue box in place. I'll go ahead and say okay. And we've got our first sheet metal part. In fact, if I turn off the cube, we can kind of see what this looks like. Now, one of the other options I showed was this unfold. So I'm going to click on unfold, and it's asking for a stationary entity. I'm going to go ahead and click on, for example, a face that I don't want to move. So I'm just going to click on this inside face. It could have been this bottom face. It really doesn't matter. And you'll notice that it highlighted all of the bends green, okay? And I can pick on an individual bend one at a time. I can even do this one down here, and it's going to keep that one bent until I click on it. Or I can just say unfold all the bends, and it's going to unfold all of the bends. I'll say okay, and here's what that would look like laid out flat. Then I can click on refold faces, and it's going to refold them back together. Now here's probably my favorite part with sheet metal. Check this out. I laid it out flat. You know, I just said unfold all bends, so it's kind of laid out flat. Then I'm going to come in here and just create a sketch. And let's just do maybe, let's do a slot. I'll just do a center to center slot. So let's just come up here, something like so. Stop my sketch. And then I'm just going to machine this through. So I'm going to just say extrude all the way through. And I'll say, okay. And so I just basically punched a slot through here. Well, notice it still says refold faces right here. I'm going to click on refold faces, and it actually refolds those faces, and you can see how that slot updated accordingly. I think this is extremely powerful. The other thing I like about this is I can use regular modeling commands. So for example, if I click on this edge, I could say, let's go ahead and fillet that edge, maybe 1 inch. I'll do the same thing over here, and maybe on this guy over here. So I'm just using regular modeling commands. I'm not having to switch from one mode to another or anything like that. I can come in here and say, maybe we want to chamfer these edges a little bit or something. So let's just say 0.2, like so. I'll say okay. And when I come to unfold, it does that. I mean, there's my chamfered edges up there. Here's my filleted edges over here. I can even do things such as offsetting faces. So I could grab this face here, press pull on it, and push it back. So something like that, for example. It's still a sheet metal part. And this is what it blows me away. Still a sheet metal part, okay? You can even mirror stuff, which I'll show here in a moment, and it remembers the mirror and everything. It's pretty cool, okay? Okay, so let me, let's do this really quick. I'm gonna talk more about the Flange command, and then we'll start creating a real part here. So I'm gonna go into inch, sheet metal, new component, sheet metal component. Let's just keep it this 0.125. I'll say okay. Create a sketch. I'm going to do a center rectangle in this case. Let's just do, I'm not going to worry about the size. I'm just going to go ahead and click and create my sheet metal part. Okay. Continuing on with the flange command, I'm going to go ahead and click on, for example, this edge and start to drag it up. And we'll make this, that's great, 2 inches tall. And you'll notice it says full edge. So it's basically bending that full edge. If I come in here and say symmetric, you'll notice I get these little arrows that appear. Okay. So I'm going to start to drag to the left. Oops, that's not good. Weird. Let me start that over. Apologize for that. Let me go ahead and get back caught up here real quick because I didn't save it. Okay, sheet metal, new component. We'll do the 0.125 again. I'll do the center rectangle. Probably shouldn't click so fast as my problem here. Okay, so I can click on an edge to pre-select it, and I'll say flange. Let's just drag this guy up. Okay. Then I can change to symmetric, grab this arrow and start to drag, and we can see how it's going to create this flange. Now, let me see if I can rotate so you can see it a little bit better. There's a dimension right here, 20.33. And you can see right here what the distance is. So symmetric is basically the distance in 2 directions. So it's basically saying this is 20 millimeters to the right and 20 millimeters to the left. So if I set this to be 10, for example, you can see how this would be 20 millimeters wide. But you'll notice that the tab is always in the center. Okay, that's the symmetric. Now, just like before, you can change the angle of these and all that kind of stuff. It's pretty self-explanatory. I could also come in here and say to side. And again, I get these arrows, but what this is going to allow me to do is to specify a distance from one side. And again, it's hard to see. So we're basically saying go 20 millimeters from the center over to here. And then I can grab this guy and say go 30 millimeters from the center over there. So let's just even that out. I'll say 20 and 30. And you can see how it's kind of off center now. Okay. So we've got 20 over here and 30 over there. So that's the two side option. Basically allows you to kind of position this tab wherever you want from center. Then we have to offset, which is the one I kind of use the most. I use, well, I should say, I use full edge, obviously. I use symmetric quite a bit, and then I use to offset quite a bit. I don't really use two side all that often. But to offset allows you to reference things. So I'm going to go ahead and start to drag this guy to the left. My mouse is acting funky. So it's referencing, you can kind of see the tag right here. It's referencing this edge. So I want this tab to be over 30 millimeters from that edge. Okay. Then I'm going to drag this guy over, and it's referencing this edge over here. And I want that to be, let's just say minus 15 in this case. And now you can see how it's creating that tab exactly where I want it. And that, you can see why I use this one quite often. I can specify how far from this edge that I want to have that tab. Okay. So those are those full edge, symmetric, two side, and two offset options. Okay, now this is a really simple example, but you can reference other faces, etc. In fact, here's a cool trick. I'm going to say full edge. Our height, let's just say, is 2 inches. I'll say OK. Then I'll go ahead and create a flange over here. So I'll click on this edge, start to drag. All I have to do is get near this other flange and click, and you'll see that it actually snaps to an existing height. So it's a really quick way to match certain things. So I start dragging up, I just click, and you can see how, in this case, it is on height datum is outer faces. I want that to be inner faces, so you can kind of see how that matches. And it's at a weird angle, so I'll make sure that's set to 90. I must have clicked the angle. So neat little trick there. Okay. I also mentioned you can mirror things, and this is what I think is really kind of slick. Let me, yep. I'm going to go ahead and create a flange over here. Let's just do this guy. We'll say it's symmetric. And let's just make it an even 10 in this case. So I'll say OK. Let's go ahead and maybe fillet this edge. Go home. I'll fillet that, make it 10, make this guy 10, say OK. We have regular modeling commands such as like hole. So I can say, put a hole on here. And here's a neat little trick. If you didn't know this, if I start to drag this blue dot, you'll see there's 2 little dots right there. I can actually snap to the center right there and say, OK. And I just positioned that hole exactly where I wanted it. OK, so I've spent a lot of time creating this. I can now come in here. Let's just prove this. I'll come in here and say unfold. Let's unfold all the bends. We can see that sure enough, that unfolds. Well, let's go back into our solid. mirror, and I want to mirror features, okay? So I'm gonna go ahead and select all of these features here, like so. My mirror plane, I'll go ahead, I could do the center if I wanted to. I'll just do that. I'll say okay, and we can see that we just mirrored across the center. Now, is it still a sheet metal component? Let's say unfold, unfold all bends. Absolutely. In other CAD systems, this would fail miserably. You'd spend a lot of time building each side, et cetera, et cetera. But the fact that Fusion is powerful enough to actually mirror a bunch of features like this to the other side is extremely powerful, I think. So, okay, so with that said, we've now learned about the flange command. There's two more in the flange command that I'm going to show. We'll talk about creating a flat pattern here in a moment. We've learned about how to unfold, and we've learned about sheet metal rules. Now, the other two things I wanted to show really quick, let me bring this guy up. So the flange command that we've been using, which is this guy right here, we use to give us our thickness. We've used it to create, a bend on the part. You can also use it to create a profile. So here I just have a basic, Z-bend profile. I'm going to say flange. I'll click on this guy. And then I'm going to click on the edge of this sheet metal part. So I'm going to click on that and notice what it does. It actually creates the bend and it joins it together into one. So using the rules, it created the correct bend radiuses. And I can even go all the way around the part. I'll click there, here, and here. And very quickly, I created this, sheet metal tray with basically a rectangle and a little Z-bend profile. Okay. So the flange command allows you to use straight edges like that. I could also come in here and say flange, but notice how this one is not touching. So I'm gonna go ahead and click on this guy, and then I'm gonna click on this edge and watch what it does. It actually joins the two together in the correct bend and K factor and all that kind of stuff. Even though these blue lines are kind of floating out here in space, it actually joined these together to create that. Now the drawback is it has to be touching the part to be able to go all the way around. So if I try and add in another edge, it's not going to work because it's not touching. So, and it tells me that. So with that in mind, check this out. I can come in here and let's just create another quick sketch. I'm just going to draw a basic shape here. So I'll draw like a horizontal, kind of an angle, come down a little bit, maybe another angle down and to the right or something. So I'm just drawing a basic, and I could dimension this and all kind of stuff. I just drew a profile. I'll click on this guy and start to drag, and we can see that it's creating the bend radiuses for me automatically, okay? And again, I can specify which side does it go on to. I can specify the depth, let's just say in this case, minus 100. And what's so neat about this is now I could come in and say, let's create a flange on this edge. Start to drag, and it's going to create the bend radiuses for me. So maybe this is some kind of sheet metal cable channel routing something. Okay. So we'll do this and this guy. And notice how it's mitering this for me automatically. Let's just leave it at that. Okay. So the fact that I could whip something out like this that quickly, I think is pretty impressive. Okay, so let's go ahead and do the outlet box. So I'm going to create a new design. I'm going to switch into inches. And again, if you have any questions, please feel free to post them into the Q&A. Okay, so I'm going to switch into sheet metal. The first thing I'm going to do is say new component. I'm just going to call this box. I want it to be a sheet metal component. And in this case, I'm going to use the 0.0625. And if we expand this open, we can see that it's using reliefs. And yeah, so this one's using the tear reliefs. So let's go ahead, and I don't want to use tear. So I'm going to come in here and edit one of these. So actually, let me cancel out. I'll come in here and let's just edit this 0.0625. And I want these to be round, and the corner reliefs I want to be round also. Okay. So now I can come in here and say box, sheet metal component. And so it was kind of cool that I actually checked that, right? I expanded this open a little bit. I just wanted to see what the conditions were and the corner conditions. So sure enough, those are round. So I'm happy. We'll go ahead and say, okay. There's my component. I'll create a sketch. And I'm going to draw on this kind of this front view. And let's just do a center rectangle. And in this case, it's 2 inches wide by 3 inches tall for the outlet box. I'll stop my sketch and use the Flange tool. Now you'll notice that it's extruding in, which is okay in this case. I'll go ahead and say okay. And there is my sheet metal part, basically. Then I'm just going to come in and start creating the actual lips. So I'm going to start to drag this, and I know that the overall distance is 2.5. Okay. Now, I said that's the overall distance, so I want to make sure, I'm measuring from the outer faces. If I said inner faces, you'll see how it just grew just a little bit more. But I know that the overall length from here to here is 2.5. Okay. And I can add multiple edges at the same time. So I'm going to go ahead and select all 4 of these edges, and it's going to create that round corner relief just like I asked it to. Okay. Now, in the example I had loaded, there's a metal tab that kind of goes over it, that kind of holds this in place. So the next thing I'm going to do is say, create a flange and start to drag. And you're going to see an issue suddenly appear. Okay. I want it to go up and over, but in this case, it's kind of coming underneath. Okay, so maybe I don't want the inside position, I want the outside position. But again, notice what's happening. In fact, I get a warning. It says it's intersecting the body, so this physically couldn't be manufactured. Let's try adjacent. Well, that gets me closer, but not quite. Okay, and then finally tangent, again, doesn't give me the result. So none of these are giving me the result that I want. So what I need to do is to actually offset this face. So I'm just going to press pull this face, and you'll see that I can actually lift it up a little bit. Okay. So let's lift that up 0.063, let's just say, in this case, and I'll say okay. We'll create a flange. Start to drag. I get kind of that same issue that we saw, but let's go ahead and say outside. Nope. We'll say adjacent, and there you can see I gave it just enough clearance. Okay. So the next thing I want to do is specify the height. So let's say it's going to be 0.5 inches. So we can see how that's going to be 0.5 inches. And I don't want it to go the full length. I want it to be symmetric. So I'm going to say symmetric and start to drag. And my machine is thinking. Wow, I am not having much luck today, am I? I apologize, guys. I've I haven't had any crashes in months, and I get two during one webinar. Um, that's very frustrating. I'm sorry. So I will, due to time constraints, I will come in and use my existing one to kind of show you what I just did there, so I don't have to start all over again. And then I'll kind of step through my timeline. So let me go ahead and load up this outlet box real quick. Hopefully. Okay, didn't double click on it. Okay. So let's go ahead and activate this guy here. And believe it or not, here are the steps involved for creating this outlet box. A very simple timeline, okay? So I'm gonna actually kind of step through. Um, so let me turn everything off here. Okay, so we started with a sketch like I showed earlier and created a flange, okay? Then exact same thing, I extruded or flanged, I should say, all four edges. And then you can see right there where I did the offset. So you can kind of see I'm gonna back up and then I'm gonna move forward. So there, I just pulled those faces up a little bit, and then same thing at the bottom. Okay, so I just did an offset face to kind of pull those faces up a little bit. Then I just did a symmetric flange, which I was just showing right there. And you can see in this example, in this material, I have a very minimal bend radius, or I'm sorry, relief, I should say. You can see how that flange flips over. And I do that on all four, or on the top two, I'm sorry. Then we do a symmetrical flange right here. So let's go ahead and see if I can continue on without it dying on me. So I'll come into sheet metal, say flange. Let's just make it 0.5 tall, and we want it symmetric. And let's just go 0.25. And maybe the height is just a little bit too big, so let's go 0.3. No, I guess it needs to be 0.5. Okay, so I'm gonna do something like that. So it's 0.25 to the right, 0.25 to the left. Then I can come in and use regular commands like fillet. So 0.25. I'll go ahead and select both of those edges. And you've already seen this, I've already shown it to you, but I'm just gonna go ahead and say hole, click somewhere on that face, specify the size that I want, in this case 0.15. And then I can just drag this around and we see those little dots appear, and I can go ahead and just snap to one of those dots and say, okay. And that's how I created that tab there, okay? Yeah, so it's gonna complain at me, so let me go ahead and suppress that guy. So then moving on, I just basically, in fact, I'm gonna undo so you can kind of see here. Okay. Round it over, create the hole. And then this is the important thing I wanted to show is you can mirror the whole thing over. So here I spent the time creating the top part of this box, and then I used the mirror command, which I showed earlier, but watch what happens to this box. It mirrors all of those features to the other side, okay? Then you'll notice I just use some regular modeling commands to kind of simulate the punch. So we don't have predefined punches or stamps. You just use regular modeling commands such as, extrude, cut, for example. Same thing with like this little recess right here. I just drew a circle and cut that into there, and then did the same thing on the bottom side. Now, if I come in here and say unfold, pick my stationary entity, and unfold all the bends, we can see, sure enough, we can unfold this box. Okay. So Isaac asked a good question, how would you create a dimple? So that is what you would consider a stamp. And again, it kind of depends on how is this going to be manufactured. So, for example, this is going to be basically stamped in there. If I wanted to create a dimple, I would just create like a revolve, but that's actually physically deforming the sheet metal. So, maybe you just marks a location and say use a standard, 0.5 dimple tool or something like that. Again, it's really up to you on how is it going to get manufactured. Okay. So yeah, we don't have stamps, we don't have punches right now. But you might see some of those down the road. And then Jerome asked a question at the very beginning, like how would you create a reinforcement crease on large sheet metal? Same thing, if you want it to unfold, it kind of has to be, all the same thickness. So I would probably just create a general note saying, manufacture a 1/4 inch crease or something like that. Or you could model it and see if that worked. Okay. I mean, we have quite a few customers using our sheet metal module, creating some pretty impressive stuff. Like that bumper on the front of the truck, for example, was one of the early ones. Um, we have customers using our sheet metal to create like cardboard boxes for packaging, plastic enclosures for printers, and all that kind of stuff. It's pretty amazing what you can do with the sheet metal module. Okay. Um, okay, moving forward here. So now that we've created this, we need to somehow manufacture it, which we were just talking about. So what I'm going to do here is under the create menu, you can see, in fact, we'll just do the box. I'll come in here and say create flat pattern. Okay. Now, pretty simple. It's asking for a stationary face. I'm going to go ahead and click on that face there and say, okay. See that it kind of switches into kind of a different mode, and it says flat pattern, solid and flat pattern surface, which is kind of neat. And then you see exit flat. Okay, so it's basically kind of showing a top-down representation of this laid out flat. And I can make changes to it. I could come in and make extrusions and add fillets and do all this kind of stuff in this representation if I wanted to. But the important thing here is you can see it says export flat pattern as DXF. So we give you a couple options here. So let's say I'm going to laser cut this, and my laser cutter requires a DXF import or something. So I could just click on this button and it's going to export this as a DXF. Okay. Or my water jet or my plasma cutter. I can also do that in my drawing package, which I'm going to show here in just a moment. Okay. So you can take a look at this. I could come in and say, fill up this edge, et cetera, et cetera. So I can do all that while it's laid out flat. And when I say exit flat, it comes back here. Okay. I don't know which edge I filleted. And if I expand this guy open, we can see right here, it says flat pattern. Now, right now it's showing a folded representation, but if I come over here and activate my flat pattern, we can see that it's showing my flat pattern. I exit my flat and it comes back to this representation. Okay. Now this is important because watch what's going to happen next. Let's go ahead and save this. I'm going to say save as, I'll just call this a demo. I want to create a drawing of this now. So I'm going to come in here and say drawing from design. I can do the full assembly. In this case, let's just do this guy. And notice right here, it says representation, folded model, or flat pattern. So I can actually specify which one I want. If I had not created a flat pattern, it would only show folded model here. Okay, so you definitely want to create a flat pattern first. And let's go ahead and specify flat pattern. Let's do maybe a C-size drawing. I'll say okay. And when it switches into my drawings, you'll see that it's going to give me a representation of the flat. You can see right there. And just like with drawings, I can change the scale, tangent edges, etc. But I'm just going to go ahead and place this like so and say okay. And it created a flat representation. Now I saw a question, and notice the fillet is represented there. I saw out on the Fusion 360 Facebook group, they were like, okay, I created a flat pattern, but I don't know what my bend angles or anything like that is. Well, to do that, you actually create a table. So I'm going to say table. And in fact, before I do that, let me change my text size to be a little bit bigger. Let's go like that. Okay. So now I can place a table. So I'll go ahead and put it like right there, for example. And you can see it created this table. Now, unfortunately, the table is kind of ugly. So here's something that I show in my drawings webinar. You can actually edit this. So I'm going to go ahead and select it, and let's just drag some of this stuff over. So I'm going to drag some of these columns, and you can see how it's going to make that look a little bit nicer. So let's just do that even a little bit further, like so. Okay, that way I can change that radius so it comes out in one level there. Okay, now kind of boring. They're all about the same size, but you can see direction up and down on some of these, and they're all numbered. Now I can move these. If I just click on them and move them off to the side, you can see that it creates these leaders for me automatically. So I just click and drag like so. Maybe I'll move this one like out of the way. I usually zoom up, but I wanted you to be able to see the table. Okay, so you can reposition where these tags are, and you can come in here and say renumber, and this is actually pretty cool. So starting number is 1. So watch what happens to my table, and maybe I want to number this in the order on how I want this to be folded. So maybe I want that to be 1. I want that to be 2, and you can kind of see how my table is updating. 3, 4. Maybe we do this guy 5 and 6. 7, 8, 9, 10, or something like that. So you can kind of see how we could renumber those very easily. Okay, now I also want to show a folded representation. So I'm going to come in here and say, I'm going to switch back to here and say drawing from design, this guy, and I want a folded representation. Now, here's a neat little trick, and again, you'll learn this in my drawings webinar. Right here it says drawing create new, but I can click on this and select the drawing that I have up here, which is right now called untitled because I haven't saved it yet. But I'm just going to say untitled. Okay. And it's going to bring in something like this. So I could do a front view. I can do my projected views off of this if I wanted to. So I can show it flat. I can also show it folded together. We'll make that shaded, for example. Okay. I can also come in here and say base view. And here it's going to do the whole assembly in this case. But let's just do maybe like a northeast isometric. And let's do a 1-to-1. So I can say, okay, and it's going to create a representation of the whole assembly. So I have a lot of options here. And again, this isn't a drawings webinar, so I'm not going to go into too much detail there. But we can kind of see what that looks like. Okay. Okay. So with that, that is the intro to sheet metal. And I apologize for the crashes that I had, which is a little frustrating. If you have any questions, please post them out into the Q&A really quick, and I will answer those for you. Again, I recommend signing up for some of the other webinars if you haven't already. I'm also doing a live stream out on YouTube every Tuesday and Thursday. In fact, I have one coming up here in just a little while, in about an hour from now, on different topics. So just do a search for out on YouTube for Fusion 360 Brent Tallis, just do my name, and you should find all of them here. So these are all the different ones that I've been doing. So I recommend signing up for these. If you hit the little bell icon, it actually reminds you when the next one's happening. So with that, I want to thank you for your time. I'll stay on for a couple more moments to see if there's any questions. And otherwise, hope to see you on a future webinar. Thank you. Okay, so somebody asked a question. In a drawing of a sheet metal flat pattern is made, does Fusion recognize and display the bend lines and the mold line? So yes, it does display basically the center line. That this dashed line is the center line of the bend, and then you can say these other edges are the tangent edges of that bend. Okay, yep, thank you. Okay, so somebody asked, how can I get an inexpensive license? So Fusion 360 is only, I think it's like $495 a year. However, if you are making less than $100,000, you can download it and try it out as like a maker or as an instructor or whatever. So you can give it a try that way. So. Okay, Isaac, thanks for letting me know about that. I need to investigate that. You're not the first person to say that, so I will take a look at that. Okay, so Dustin asked a really good question. Can I change the bend ID to make like bend 8 be bend 10? So I showed you how you can renumber them, but yeah, I don't think you can come in and say, I want this particular bend 8 to be something else. You would actually have to come in here and say, renumber, and click on that guy. In fact, I could come in here and say, make this bend number 20, and I'll click on that, and I just forced it to be bend number 20. So you could do it like that, for example, but yeah, you can't come in here and change those. Okay. Okay, so Matt asked a really good question. What about taking the sheet metal part into CAM? So let me actually, that's a really good, I just showed drawings. If you guys can hang on for a few more moments, I will actually show this live because that's a great question. So I've got this guy, I've got the flat pattern. I'm gonna go ahead and activate this flat pattern, okay? Then I'm gonna switch into manufacture. If I expand open models, you'll see there is my flat pattern. So I'm going to come in here and activate that guy, and there he is. Okay, that's the important thing. And unfortunately, it's kind of hidden. You have to expand open models and activate your flat pattern. Okay, so now here's basically my 3D model that I'm going to manufacture. So I could come in here and do my setup. I could specify, where my 0, 0 is. Let's just say it's on that corner of my material. Okay. What's my operation type? I could say milling, turning, or cutting. So I'm just going to do cutting in this case. I'll say OK. And then I'm going to use my 2D profile right here, this cutting. So I click on that guy, specify my tool. And I know I'm going kind of at a pretty good pace here, but so I'm going to come in here and let's do, where are my samples? Let me do sample holders. Here we go, profile. Okay, so I have a sample profile there. So it shows a plasma, a laser, or a water jet. So let's just say in this case, we're going to do a water jet. I'll say okay. Then I can come over to my geometry And I would just click on that, and you can see how it's going to create a profile that goes all the way around. I can even come in and add tabs if I want to, so you can see how it's going to default add some tabs to this. And I can do whatever width, what my tab positioning is. I can specify certain points or by distance. So I'm basically saying every 50 millimeters, throw down a tab. So I'm going to go ahead and say OK, and it's going to create that profile for me. Okay, and if I were to simulate this, go ahead and turn on the stock, hit play. So it's just going to basically walk around and cut with a water jet, and you can kind of see where it's going to lift up or turn off or whatever for the particular tabs. And that's it, honestly. So hopefully that answers your question at a 30,000 foot level, how you would manufacture this in CAM. So, I mean, I could use, a 16th inch cutter, 2 flute, 3 flute, whatever, cut around it. Maybe we're cutting this out of foam, or we're cutting it out of cardboard or something like that. I can do laser, plasma, water jet, whatever. So, okay. Sean, I'm not sure I understand your question. How do I slot a bend for easier bending? I will admit I'm not a professional sheet metal person, so if that's a specific terminology for doing something, I'm not sure. So I apologize for not being able to answer that. Yeah, nesting. Somebody asked nesting. So yes, definitely. We're working on nesting. I don't know when that's going to be out. So okay. So Matt, thank you for asking that question. I really appreciate it. Again, I apologize. I have to hop off now to get ready for my live stream. Hopefully you found this beneficial, and I hope to see you on a future webinar. Thank you.